Good afternoon. So I'm going to start by asking a few questions. Who here is doing sequential execution or considering doing it soon? It's actually a lot more than I thought. Who here is just here to mock me for even suggesting such a thing? Yes, you're the people I came for. So this talk is about sequentially ordered execution in SaltStack. My name is Ryan Lane. I'm a DevOps engineer for Lyft. I work on a small DevOps team, roughly 4 people. We do tooling, we do consulting and such. We do not actually do the majority of the operations in our organization. So first I'm going to start off by why am I even doing this talk? Isn't Salt sequentially ordered by default? Yes, it is. So I'm just going to stop and leave. It's not really sequentially ordered. It is if you use none of the requisites at all. Basically, every requisite that Salt has will modify the order of the execution of the states in Salt. Of course, then, still why? Why even, what's the point of this talk? Why don't we just use the requisites? Don't they ensure good behavior? They don't. So it really depends on how you think about this. If you are perfect at doing requisites, you always use requires on every single state, they can ensure good behavior if none of your states ever fail. What they mostly do is mask problems. So you have a state run that goes through, and halfway through, one of your states fails, and every requisite after that just doesn't run. What do you do at that point in time? Do you send an alert? Do you stop our deployment? Do you rerun the salt.highstate so that it eventually comes into consistency? This is not really great behavior. It's a lot better to actually fail at a point and see what caused the failure and fix the failure. No worries. So the real reason why, for at least Lyft, is that sequentially ordered states are easier to understand. You look at the code, it reads in a specific order, that's the order it runs in. The reason that this is easier for us is because we operate on the mindset, if you build it, you run it. So our developers are responsible for their own services. This includes the operation of their services, the monitoring of their services, the alerting. They're the people that are on call. They get paged, the operations team does not. So they can escalate to us, but in this scenario, they actually need to understand how configuration management orchestration works, and they need to be able to modify it because they're the ones that maintain it. In this scenario, we act as consultants. As I was mentioning earlier, we write tooling. We ensure a set of consistency between our services. Our architecture is very heavily service-based. We have a very large number of services and a large number of environments. A small operations team can't handle this well, which is why we have service teams that are responsible for their own services. But we do want to ensure consistency between all of the services. So we provide basically frameworks for them to use. A base set of states that work across all of the systems that make all of the systems look very consistent. But we also want to ensure that all of these teams can act very autonomously. So we may have Apache on API and tolls, for instance. And on these services, we want to ensure that if a person on API needs to modify their Apache configuration, that they don't have to coordinate with people on tolls. So from this regard, we've broken up our architecture into these 2 separate places where our Salt configuration lives. We have shared configuration in a base repository that all services use, but this only handles things that all services have to have to make them consistent for our architecture. So they'll have things like statsd, collectd, Splunk logging, users that need to be on the system, all of the basics of a system, the security, which includes packages that need to be a specific version for security reasons, et cetera. Then we also have, in every single different service repository, we have Salt that is Salt code that's embedded into the repository. This maintains everything about their service. So for instance, if they're using Apache, their Apache configuration is inside of this. Like if they're using PHP, it's there. The stuff that defines how their service is configured is also here. The basic is that a service maintainer can maintain everything that is specific to their own service. This does cause problems with services having duplicate code across repositories, but in each one, the service owner is responsible for their own. So it doesn't actually matter so much that we have duplicated code for most of these. And the DevOps team will go across repositories and apply best practices or encourage teams to encourage best practices by communicating them across teams. Another reason why is that sequentially ordered states are more repeatable. This is especially true if you're running if you're using fail-hard, but the basic idea is that no matter how many times you run your Salt, you run Salt, it will always be in the exact same state. Even if you put a new requisite in, it will be in the same state, except you will now have a new thing that runs in between this thing and this thing. This definitely makes the consistency across clusters much higher. So if you push out code that causes a failed high state, it will actually fail in a place, and it will make you fix this. And even if a new node is coming in from like an auto-scaling event, it will come in a broken state, and then it will have to be fixed by another code deploy. From the developer's point of view, what they see, and this is the only steps that they have to take to do a deployment that actually causes orchestration tasks or configuration management, et cetera. But from their point of view, all they see is the normal developer process. They make a feature branch, they push it into GitHub, they get reviewed, they ensure all of their tests are passing, they merge their pull requests, and then they start a deployment via Jenkins. And then we have a set of orchestration tests that run and a set of configuration management tests that run. We're kind of weird in that we run in a completely masterless environment. But in either case, it would work similarly in masterless or master, depending on how your deployment works. In our specific case, we run orchestration tasks from the Jenkins server. And for this, we generate an artifact from the code base that is for a specific SHA. We push it into S3. We release this to an environment, which could be staging, production, a canary server for production, et cetera. And then after doing so, and basically when I say release to an environment, we're saying this environment should be running this SHA. Then the Jenkins server will run the orchestration code, which makes sure that any of the orchestrated portions of the infrastructure are good. This also occurs through Salt. On the configuration management side, which is on the virtual machines, what the systems will do is they will fetch their artifacts from S3. We also have this concept of a next state of a system and the current state of a system. So the first thing that we do is we point a next link at the SHA that should be running. Then Salt is always pointed at this. When it runs, it will go all the way through and it will change the state of the system to what is supposed to be next. If it fails for any reason, it fails, and then the deployment job also fails, and then that is propagated to the user in Jenkins that shows that the deployment has failed. They'll then go into Splunk, make sure that, see what actually caused the failure, and fix that, do a new deployment, which will cause a new deployment to go through, do all of these same steps. If Salt successfully runs, then the state of the system is changed. The current link is pointing to the SHA, and then we do post-deployment steps. So the post-deployment here would also be calling Salt, but a single state that would do things like hopping Apache, if it's an Apache service, restarting Python services if it's a Python service. The basic idea is that the running process that is actually running the service, all of that stays in memory. So even if Salt changes the state of the system and it fails, the system is still running in its current state until this occurs. This is how we're dealing with atomic deployments. Afterwards, it reports its status back. From a developer's point of view, this is actually what they see for deployment. They just see a Jenkins pipeline, green meaning it was successful, yellow meaning it's in progress, red meaning that it has failed. Another reason why is that when you're building Docker images, requisites are just completely unnecessary. You don't need to start services. You don't need to restart services. The way that we're building Docker containers is that we have fat containers, and we're managing both the host and the Docker containers themselves using Salt. So the containers, we actually have no Docker files. We do a Docker build, or we do a Docker run and commit. So for each one of these, it starts a container, runs Salt, and then we have a set of things that just tell the services to start. And when we pull down new images and start them as containers, all it actually has to do at that point in time is start its services. So for us, in this particular case, there's no need to ever have to have requisites. We're currently not using this in production. We're just using it in development and in CI. But once we go to production, we'll have no need for requisites at all. Of course, if you want to hear more about how we're dealing with Docker and AWS and such, I'm giving a talk on masterless SaltStack at scale tomorrow at 10:45 in Riviera. If you've seen the new Bodo modules, I'm giving a pretty in-depth overview of the Bodo modules. So if you're doing AWS at all, this is a very good talk to go to, whether or not you're going to use masterless. So how are we actually doing this? As I mentioned, we have two different things. We have the base repository, and then we have a service-specific repository. The way that we run these things is we always include base first, and then we always include the service. So the way that our states run is that all of the base requirements are there before the service starts anything. This allows us to have our developers only care about their own code. They know that their system is coming up in a specific way, that it has things available to it. Then they only have to do the things that they care about. So whether it's installing Apache or running a Python service, et cetera, all they have to care about is that specific portion. So when they're reading the code, the only thing they have to read is their own code. If for some reason base fails, they will page us, and we'll have to fix base. Or maybe they'll fix base. It's sequential, so they can usually fix it themselves too. But another thing that we do is we have a very small number of modules. I know this is a weird thing and that we're supposed to be doing code reuse, but in reality, code reuse in configuration management systems is terrible. I've never used a configuration management system that can properly do code reuse. Since we have, in general, we have a service repository and then a base repository, the service repository is generally one file. That one file is usually somewhere in the order of 50 lines of code to 100 lines of code for every service, which makes the amount of code that people have to worry about very small. Inside of the base repository, we have a very large amount of code, but most of it is also handled in a single file. We do split certain things into modules, but those modules are included in order. So from our perspective, they're all just, it's just ways of reducing the number of lines of code in each module. Every one of the modules is meant to do a specific thing. So we'll have one that does users, we'll have one that installs a base set of packages, one that installs Splunk, et cetera. But when it includes them in order. Also, we have a very high amount of consistency between our services. We do have a large number of services that are basically external third-party software tools. But for those, there's definitely no reason for module reuse, because for each one of those, we're going to run one. We're not like going to have 5 different Graphite servers. They're all going to have the exact same module. We're only going to run one of them. We're not going to reuse that module anywhere else, so it doesn't make any sense to write a reusable module for it, especially since it's going to be pretty specific to us in the configuration. By doing this, it means that we don't have to have a lot of abstraction in our modules either, which makes the code much simpler. So for the consistency of the actual services themselves, we have a certain number of programming languages. We have PHP, we have Python, we have Go. For each one of these things, we do have a base module that can be used to make the launch of this very simple, to where they can include a module, include a few sets of code in their own repository, and then they get most of the setup for it. Or they can just copy the module in themselves if they need to make major modifications. But the idea is for each one of the different services, they include a specific thing, and then they all look exactly the same. They all send their logs to the same locations. They all send their metrics to localhost, since statsd is running there. Basically, everything about their service looks exactly like basically every other service. If it's a Python service, it's not going to look like a PHP service or a Go service, but every Go service looks like every other Go service. Every Python service looks like every other Python service. Also, we use failhard. This allows us to quickly propagate the failures through our deployment system back to the developers so that they can see what's going on. So let's look at the actual issues with sequentially executed Salt. As I mentioned earlier, the requisites will change the order of states. So for instance, if you use watch, watch will change the order of your states. You cannot use watch for the most part. In this example, or I should start by saying in 2014.7, I requested a feature because we were doing sequentially executed Salt, but watch was reordering our states. So I requested a feature that would run that would be able to run requisites after all states have run. So the idea here is we're installing Apache, we're ensuring that it's running, and then we're ensuring that it's configured in a specific way. But instead of using a watch here, which would trigger a restart of the service, we say listen, which will trigger a restart of the service, but it will wait until the very end of the run to do so. So everything will continue running in the order that it's set, and at the very end, all of the things that have been triggered will also be triggered in order. Now, that said, there's still some cases where you have to use watch. So for instance, if you need to do an action, and then immediately have an action follow that is triggered, you have to use watch. So in this case, I'm making sure that MongoDB is running, and then I configure it, but I need it to immediately restart because then the next state that I'm using after this is ensuring that a user is present, and I need to make sure that it's configured and running properly before I add users. So in this case, by using the watch, since I'm doing these in a specific order, and I know the order that the watch is going to happen since it's happening immediately after, it's still running in order. But when you use watch this way, you have to pay attention to how you're doing the watches. Otherwise, you will have weirdly ordered states. This is another example of creating the user and then populating the database with the user immediately after the creation. There's also something that you have to worry about with this is include order. So can anyone tell me what the inclusion order here is going to be? Anyone? How is this going to execute? Probably not as you think. Especially with this. Now take that earlier one, and now what is this going to do? So this is going to install Apache. It's going to include a vhost, which is going to be configuration. And then it's going to ensure Apache has started. Is this going to work, or is it going to fail? This is going to fail. And the reason for this is because include is implicitly a require. When you include another module, you are requiring another module. It actually happens before this module runs. So for this, the inclusion order for this was base first, and then the vhost, which is just ridiculous. Like the very first thing that is being included is the very last thing that you're reading, basically. Then it's going to include Apache, and then I'm not sure why I have Redis there, but oh, this is from my blog, and I pulled something out. Anyway, so what you can do here instead is if you need to include something in a specific order, you can do module imports through Jinja. It will look in the Salt path by default. The only difference here is that you have to include the .sls postfix. So in this case, it's going to install Apache, and then it will configure Apache, and then it will ensure that it's started. Also, you need to watch out about Jinja and YAML ordering. This is, of course, the case whether you're using masterless or not. But I'm sorry, if you're doing sequential ordering or if you're doing requisites. But in this specific case, your code will read out of not only, it will execute out of order in this when you're reading it this way. So it's something you have to pay attention to. What we want to do here is create an ELB and then get its configuration, and then use that configuration to create a CNAME that points at the ELB. Unfortunately, this is not going to work because the Jinja is going to run first. This is the same in both cases, but this is just something that will throw off people who are reading the code in order. There's also some patterns that can be used. So, and this is also something that can be used whether you're using whether you're using sequential ordering or not. In maybe 2014.7 or 2015.2, I added a feature so that you can reload grains during a state run in memory. So in this specific case, I am setting the host name for a system, and then I'm telling it to reload its grains. That way, if later in the state run I need to use these grains for some reason, they're available. This also works with pillars. So, this is another example of grain patterns. So, since we have this deployment model where we will do a high state run and then we run post deployment hooks, we actually have the ability to pull out some of our requisites and instead use grains. So in our high state run, at some point in time in the high state run, we can trigger a grain to be set. Specifically, we want to ensure that our post-deploy runs. So if the salt state runs and changes something that's going to require the restart of a service, we can set a grain instead of doing a requisite. That way, in our post-deployment, which is called via state.sls, we can check the value of the grain, restart the service, and then set that grain value to false. Pillars also can be used, can be reloaded. So that in this example, we're setting a value in etcd, and then we tell it to reload the pillars, and then later we configure another service, or really even this service. We reconfigure etcd by itself. It's weird. Anyway, so in this case, inside of the etcd.conf, it's using pillars that are pulled from etcd, but specifically the one that was just set. This also can be used whether it's sequentially ordered or not, but in both the case of the grains and the pillars, this makes doing sequential ordering much, much easier, because you can change the state of your system in one place and then know that later in your code that is now available. So I know this talk has been about doing sequential ordering, but I'm not a purist. I don't think anyone is. And Salt is awesome, and it allows out-of-state execution, so why not embrace it? There are some cases where you want to do, where everything is going to be sequentially ordered, but you may want to define something in base that actually executes after your service. So that way your service can modify something that then gets included later. So we have something that shows up in the message of the day where people can SSH into the system, and they can see the different salt states that they can run to modify the system, like for instance, registering or deregistering a system from its own ELB, running a high state, disabling high state, and a few other things that they can run. So throughout our code base, we have places where we're injecting this into a grain, and then we want to ensure that the message of the day is actually defined last. That way we can inject it everywhere in the code, and the very last thing that happens is it generates the message of the day. There's a number of other cases where embracing reordering is really great. Of course, in our code base, this would have a gigantic warning above it that says you should never use order. It reorders states. It makes things confusing. You should probably consider another way of doing whatever you're doing if you're using this as an example, et cetera. And we also put those warnings everywhere we have watches, too. The configuration of our system, you may not be able to read all of this. In our config, the very first thing that is set is that we have fail hard. And then we have a configuration that points at two different locations for service and base. Our top file is actually pulled from the service and not from base. So that's why it's included before base. That way the top file gets included. It's unfortunate, but whichever top file is picked first is the one that wins. So you have to include it that way. From the pillar and state tops, they're very basic, especially the state top. It just says include the base and include the service. We have grains that are set for our service names, environments, et cetera, so ignore where you see these things. But for the pillars, we include the base, and then we include the service pillars, and then we also have the ability to include pillars that are specific to environments. You should never do this in master minion mode, ever. Never do this, because it's insecure. In masterless mode, this works fine. So there's definitely some issues with this. Formulas, I wrote mostly unusable here. They're completely unusable. If you're doing sequential ordering, I don't think there is a single formula in the repository that does sequential ordering. They all have requisites. A lot of them have requisites which require other formulas. Your developers will not understand this. If you were doing sequential ordering and you include some formulas, they will have no idea what's going on. Also, there are some modules that require requisites. For instance, file.accumulated requires that you use require. If you don't add require to that module, it will just fail. This is the case for a number of other modules too. It would be really nice if this was not the case. Also, fail hard support is sometimes spotty. I don't think it's tested as well as having it turned off. So for instance, it may be fixed in a newest version of Salt, but things like on fail, instead of actually working, just fail and cause a state failure. So it would be nice to have some of these things fixed, but I'll probably just not care about the formula support. Some features I would really like to have for this is a queue requisite. So we have the listen in requisite, which allows you to trigger states at the very end of a run. But sometimes we also want to trigger a set of states, but we want to choose when they're actually executed. So we may have a case where we install a set of supervisor D configuration files, and for each one of them, we want to run supervisor updates so that the services start and are actually populated in supervisor. It would be nice, instead of having to like hit each one of these and have a different state ID or name for each one of these services, to be able to say, I want to pop this onto the queue, pop it on the queue, pop it on the queue, pop it on the queue, and at this point in time, execute. So it's somewhere in between watch and listen. Also, the include support, even though the Jinja thing works, it kind of sucks. It would be really nice for this to work natively in Salt, to say, like, basically include here instead of require. Thank you for your time. And if anyone has questions, please ask. Yes.
The part where you're loading up the grains and the pillars and then reloading them later on, do you guys do reboots in between? So you run some configuration, change this service, that service, and then whatever about what you're doing requires a restart, you have to go back later and do something else after that? Is that?
No. So the question was, when we're doing reloads of grains and pillars, do we do restarts of, do you mean Salt, or do you mean?
You could use the grain changes as like a flag so that it can come back later on when that system boots back up, it automatically kicks off high state.
Oh, I see.
It can pick up on what that new grain value is.
Right, so you're asking if we're setting grain values so that they can be used in further Salt runs. Yes, we are doing that. So one of the examples that I gave is this one. So we're running a high state, we're setting a grain, and then later we're doing a run of a single state that checks the value of that grain, does an action, and then unsets it. We do this in a number of cases. This is our main case for this. We also use it when we're building Docker images. We have grains that are set when we start the build so that it knows it's in building mode, basically. We actually don't use Docker build, but similar idea is that it knows that it's building instead of running. And then later runs will not have that set. Yes?
In cases like this where you're just flipping the bit in the grain, what's the benefit of that over listening?
The question is, what is the benefit of setting and unsetting the grain rather than using listen? So this is specifically between runs. So we have a high state run, and then after the high state run is finished, we're coming back and running something. So it's basically just a means of keeping state between runs. The question is, why would I run masterless? You should come to the talk to find out. The biggest reason for us is that Salt currently is difficult to run in an HA mode. Even the current HA support and the clustering does not is not very good. It's unclear when you're doing events or when you're doing calls where the data is actually going, which master it's going to hit. It's unclear what will happen if one of the masters fails. A lot of the system is pretty unclear. And we run in Amazon with multiple availability zones, and we assume that at any point in time we can lose an entire availability zone and continue running. And if Salt cannot run during this outage, then it's problematic. So we want to ensure that any portion of our system can run without an entire availability zone running. And that's the primary motivation that we have for not running a master. Additionally, if you're running a master, all of your files and all of your pillars and everything else that is accessed from Salt goes through the master. In our case, we find that it's faster and more reliable and easier to scale if we don't have to worry about scaling our master, which if our files are all there and our pillars are all there, then we have to worry about that. By deploying all of the code out to the systems, it bypasses that completely. Any other questions? Yes?
Have you considered any other renderers to address some of these issues?
The question.
Or are you writing your own renderer?
Right. The question is, have we considered using different renderers to solve these issues? The good thing is we don't really have that many issues. A number of developers that I've spoken to recently have said, it's so simple. So the way that we have things working currently, it works really well, and we just have to watch out for a few issues that would cause state reordering. Even if we were to use a different renderer, we would still have the issue where we have the possibility of running code out of order. Any other questions? Great, thank you for your time.